So the last few problems, simply because I ran out of time. All right, so again, I see a whole bunch of e's. And this time I see that I have a mess underneath something or on the inside of something. So I'm going to use U-substitution. So u equals the inside of my radical, which makes du equal, so how do I take the derivative of an e to the? I write what's sitting there, times the derivative of my exponent. Don't forget your negative that's coming along for the ride. Which means I have an e to the x and a dx. I just need a negative. So multiply by a negative, balance with a negative. So now what I have is the integral of u to the positive 1/2 du, because this is your u to the 1/2, and then there's your du. So that integral becomes negative u to the 3/2 over 3/2 means times 2/3 plus c. But you started in x world, so you better end in x world. So 3/2 plus c, and then what was your u? It was a 3 minus e to the x. Okay, so that's your integral. Now, let's do another one. We have the integral of 4 minus e to the x over e to the 9x dx, and I'm slightly traumatized because I'm not quite sure what to do. So as soon as I see a fraction, the first thing I do is the derivative of the bottom in the top, and it's not at all, okay? But what do I have? I have got two terms in my numerator, so I can separate this out into two separate terms. And so I'm going to rewrite this thing as a 4 times e to the negative 9x, because I'm bringing this negative 9 up top with a 4, dx, and then minus an e to the x. Remember, if you've got the same base, you subtract your exponents if you're dividing. So 1x minus 9x's is negative 8x's. So this becomes e to the negative 8x dx. And both of these I know how to integrate. So on this one, I notice I have an e to the, and so I need to make sure I've got the derivative of my exponent. So for this one, I've got my u is a negative 9x. So my du is a negative 9 dx. Well, I have a 4. So I'm going to pull that 4 out front and magically make this into a 9. Okay. So I need a negative 9. So I'm going to balance with a negative 9. So this becomes a negative 4/9 e to the u du. Okay. And if we want to finish that, that becomes a negative 4/9 e to the u, which is a negative 9x, plus c. But I'm fixing to add this to it, so I'm just going to put the plus c at the end. So on this one, my u is a negative 8. What am I doing? Is a negative 8x. And then my du is a negative 8 dx. So I need a negative 8. So balance with a negative 8, which makes this addition. So now what do I have? I have plus 8 times e to the u du. So now I've got a plus 8 e to the u, which is negative 8x plus c. And then that one's done. All right, so the next one, I'm going to do it two different ways. We're going to use U-substitution, and then I'm going to do it again. Because remember, back in chapter 4, we ended up, as long as we were in U world, then I changed my limits of integration into terms of U. And that way I didn't have to backtrack. So up here, I had to backtrack. I was in U, and then I had to go back to X's. Well, if I find what U is, then I don't have to do all that mess. So what is she saying in real life? What I have is an e to the 7x over a 1 plus e to the 7x dx. Okay, so now is the derivative of the bottom in the top. Well, the derivative of the bottom, this will be 0, and this will be e to the 7x dx times 7. Okay, so I can go ahead and take this times 7, balance it with a 1/7, and now this naturally goes to, if the derivative of the bottom is in the top, the integral becomes the natural log of the bottom. So 1 plus e to the 7x. But we're going to take this and go from 0 to 2. Okay? So that being said, if I evaluate with a 2, I will get 1/7 times the natural log of 1 plus e to the 14th minus, and then what happens if I shove in a 0? So this will go to e to the 0, which is 1 plus 1. Okay? So I'll have minus 1/7 natural log of 1 plus 1 becomes 2. Okay, so that's your answer. And literally on this one, you don't have to have the absolute values because 1 is positive and e to the 14th is positive. It won't count you wrong if you use it. All right, so what happens if we do it the other way just for kicks and for practice? So if I said that you're going to use U-Substitution, so again, we're going to get the same answer. It's just going to be a different format. Then I have an e to the 7x over a 1 plus e to the 7x dx. So if I make my u my denominator, what is on my finger? All right, e to the 7x, then my du is 7 e to the 7x dx, okay? Which means I need a 7, so balance with a 7. So here's your 1/7 and here's your 7. But here's what I'm trying to scream at you about. As long as I'm changing this into u's and du's, because I'm fixing to rewrite this as a u, and then this entire numerator will become a du. So I've got a 1/7 times the integral of 1 du over a u. So go ahead and change your limits of integration as well. Okay, so what do I get if I shove in a 2? I get a 1 plus e to the 14th. Okay, so this becomes a 1 plus e to the 14th. What happens if I shove in a 0? So all I'm doing is evaluating what this is in x world to find out what it is in u world. So always shove it in here. All right, so if I shove in a 0, I get 1 plus e to the 0, which is 1 plus 1, which is 2. And so now when I integrate this, I get a 1/7 natural log of u, okay, because the derivative of the bottom is in the top. And now I can evaluate that going from a 1 plus e to the 14th and going down to a 2. So now slap this stuff in. I get a 1/7 natural log of 1 plus e to the 14th and then minus 1/7 natural log of 2, which is exactly what I got up here. And so if I were given a choice between these two methods, this one to me was easier because I really didn't have to rewrite in terms of u's. But I just wanted to give you a refresher, especially if you're going into Cal 2. Leaving your limits of integration in terms of x can get pretty messy. So as long as you're substituting into u's with a definite integral, it's easier to evaluate with your x's and then change your limits of integration into u world. All right, so the last one we've got on this section is find the general solution of the equation, differential equation. So dy dx equals 5e to the x, so 5e to the x minus 9e to the negative x, and I'm going to square that. And again, this little format right here in Cal 2 is going to be awfully handy. So if you'll notice, I'm squaring something, and my first term has an e to the x, and my last term has an e to the negative x. So I'm going to go ahead and FOIL this thing out. So remember, I'm going to take this thing times itself. Okay, don't distribute that 2. So what I've got right now is dy dx equals 5e to the x times 5e to the x gives me 25e to the 2x. So remember, if you have an e to the x times an e to the x, hang on, I'm going to rewrite this for you. So minus 9e to the negative x, 5e to the x minus 9e to the negative x, okay? So if I'm multiplying the same bases, you add your exponents. So e to the 1x times e to the 1x becomes e to the 2x, okay? Multiplying outside, I'm going to get a negative 45, and then I'm going to have an e to the x times an e to the negative x. Well, what happens with that? An e to the x times an e to the negative x, your bases are the same, so add your exponents. So what's an x minus an x? It's a 0. Okay, so this turns into a 1. Okay, exact same thing on the inner side, so I get minus another 45, and then I'm going to have plus 81 e to the negative 2x. Okay, so all I have done is rewrite this thing. So I'm going to simplify it just a little bit. And what I'm going to also do is I'm going to slap my dx on the other side, multiply both sides by dx. So I got dy equals, and then this is going to become the integral of 25e to the 2x minus 90, okay, and then plus 81e to the negative 2x dx. So now I've got to do is integrate. So the integral of 1 dy is y. The integral of, so this time I'm going to try and do it without writing all the u's and stuff. I have an e to the derivative of my exponent is 2. So I need a 2, so balance with a 2. Okay, that says e to the 2x dx, so I need a 2. So now I've got 25 halves e to the 2x. Okay, for this one, the integral of negative 90 is negative 90x. This one, I have an e to the 2x, so 81 is coming out front. E to the negative 2x dx means I need a negative 2, so balance with a negative 2. So that becomes minus 81 halves e to the negative 2x plus c. And that is section 5.4, I think.